3-Eye Atlas is an object unlike any other observed in the solar system. Its discovery has sparked significant interest among astronomers as it marks the first confirmed interstellar object to pass through our system. The object's name, 3-Eyes Atlas, derives from its initial identification by the Atlas Asteroid Terrestrial Impact Last Alert System Survey, a project designed to identify near-Earth objects. What sets 3-Eye Atlas apart from other space objects, however, is its origin. Unlike comets and asteroids that originate within the solar system, 3-Eye Atlas is believed to have traveled from another star system. Its trajectory through the solar neighborhood has been observed with increasing precision, revealing peculiar characteristics that challenge scientists' understanding of interstellar objects. Its discovery is a milestone in astronomy, marking a new chapter in the study of objects that come from beyond our familiar celestial sphere. The first hint of 3-Eye Atlas's unusual nature came from its rapid motion. When the object was first detected, its speed and trajectory were inconsistent with what astronomers would expect from objects in the solar system. Most comets and asteroids follow relatively predictable paths, influenced by gravitational interactions with the Sun and the planets. But 3-Eye Atlas's path seemed different. Its velocity was too high, suggesting it was not bound to the Sun's gravity, but rather was simply passing through. This was the first clue that 3-Eye Atlas might not be a typical solar system object. Its journey had begun far outside the region of the planets, making it an interstellar traveler, a wanderer from the vast unknown regions of space. The unique velocity of 3-Eye Atlas combined with its trajectory led astronomers to quickly suspect it came from another star system. Its highly elliptical orbit suggested it had been moving through the galaxy for millions of years, only recently entering the solar system's vicinity. Such interstellar objects were previously theorized to exist, but until 3-Eye Atlas, no object had been definitively detected. This discovery opened a new window into the study of objects from other star systems, offering a glimpse of what lies beyond the familiar bounds of the Sun's influence. As the object continued to travel through the solar system, scientists began to scrutinize every detail of its movement, hoping to unlock more clues about its origin and nature. What makes 3-Eye Atlas even more intriguing is its unusual physical characteristics. Unlike most comets, which are primarily composed of ice and dust, 3-Eye Atlas does not exhibit the bright coma and tail that are typically associated with comets as they approach the Sun. Instead, its behavior and structure have suggested that it may be composed of more solid material, possibly an asteroid-like composition. This has raised questions about how an object from another star system could have the physical properties of a comet or asteroid, blending features of both types of celestial bodies. The lack of a typical comet tail, often the result of sublimating ice as an object warms near the Sun, suggests that 3-Eye Atlas may not be as volatile as a regular comet. Instead, it appears to be a more stable object, perhaps composed of rock or metal with only subtle signs of interaction with the Sun's radiation. Despite the lack of typical cometary features, 3-Eye Atlas's high velocity and its apparent non-gravitational acceleration have puzzled scientists. Objects that pass through the solar system typically experience gravitational interactions with the Sun that can change their speed and direction. However, 3-Eye Atlas has shown a pattern of motion that suggests an additional force is at play, one that is not easily explained by known gravitational mechanics. This has led to debates among scientists as to what might be influencing its motion. Could there be an unknown interaction between the object and the solar wind? Or perhaps an unseen force is acting on it, one that requires a new understanding of interstellar object dynamics. These questions remain unanswered, and 3I Atlas continues to be the subject of intense study. The discovery of 3I Atlas has also raised broader questions about the nature of interstellar space. For centuries, scientists have speculated about the possibility of objects traveling between stars, but only with the detection of 3I Atlas has this theory been confirmed. The implications of this discovery are profound. It suggests that objects are constantly moving between star systems, perhaps even colliding or interacting with one another in ways that are not yet understood. The very fact that 3I Atlas was able to travel across such vast distances without disintegrating or being affected by external forces speaks to the resilience and longevity of such objects. It offers a glimpse into a universe that is far more dynamic and interconnected than previously thought, where objects move between stars with a freedom and autonomy that defies our typical understanding of space and time. As the object continues to pass through the solar system, astronomers are carefully monitoring its trajectory. Its path has been mapped with increasing precision, and more data is being gathered with each passing day. The objective is not only to track 3I Atlas's current movement, but also to understand its long-term trajectory. How did it end up in the solar system? Will it continue its journey out of the system, or could it become trapped by the sun's gravity, eventually settling into a more stable orbit? These questions remain a mystery, and scientists are eager to observe how this object's journey unfolds. The discovery of 3I Atlas has also prompted a reevaluation of how we view objects in our own solar system. Until now, objects in the solar system have been thought of as the remnants of our own planetary formation materials that were left behind after the sun and planets formed. But 3I Atlas challenges this view. It suggests that the solar system is not a closed system, but rather a place where objects from other star systems occasionally wander in. This realization has opened up new avenues of exploration. Could there be more interstellar objects yet to be discovered? What else might be out there beyond the confines of our familiar solar neighborhood? 3I Atlas is not just an object to be studied in isolation. It is a symbol of the unknown, a messenger from the broader universe, reminding us that the cosmos is far more expansive and mysterious than we can imagine. The questions it raises are not just about its own peculiarities, but about the very nature of the universe and the forces that govern its vastness. What we learn from studying 3I Atlas could provide valuable insights into the formation of our solar system, the movement of objects between stars, and the unknown factors that affect the dynamics of interstellar objects. As the object continues its journey, one thing is certain: the scientific community will be following its path closely, eager to unlock the secrets it holds. Whether 3I Atlas is a harbinger of more interstellar objects to come, or simply an anomaly in the vast reaches of space, it has already made its mark on astronomy. Its discovery is a testament to the power of scientific observation and the mysteries that still lie ahead waiting to be uncovered. The journey of 3I Atlas to our solar system is a remarkable tale, one that began millions of years ago, long before its arrival in 2017. In fact, its origins are as mysterious as the object itself. Though the object's trajectory has been traced with increasing precision, the full story of where 3I Atlas came from is still largely unknown. It is believed to have originated from another star system, making it the first confirmed interstellar object to pass through the solar system. The journey of 3I Atlas raises profound questions about the nature of our galaxy, the vast distances between stars, and the forces that propel objects across these distances. For years, scientists have theorized that objects from outside our solar system could pass through, but until 3I Atlas, no such object had been observed. Its arrival in the inner parts of our solar system, however, did not happen by chance. The object's trajectory suggests that it was following a path through the galaxy, potentially for millions of years, before it entered the reach of the Sun. What caused 3I Atlas to change its course to come so close to our solar system? This is one of the first mysteries surrounding its journey. The path of 3I Atlas has not been a simple, straightforward line through space. Instead, it has followed a complex, highly elliptical orbit, one that suggests interactions with other objects or forces at play beyond the Sun's gravitational influence. It is important to note that 3I Atlas is not alone in its journey. The interstellar medium, the region of space filled with gas and dust, is not empty. While the vastness of space can seem empty, it is far from it. The gravitational influence of nearby stars, the movement of other objects, and the scattered material in the interstellar medium can all impact the trajectory of an object like 3I Atlas. As it traveled through the galaxy, it could have interacted with other star systems, potentially altering its path and setting it on a course toward the solar system. The question of whether 3I Atlas was deliberately directed toward our system, or whether its arrival was purely by chance, remains a matter of debate among astronomers. Once 3I Atlas entered the solar system, its path became even more significant. The object's velocity, which was too high to be gravitationally bound to the Sun, suggested that it was not a permanent visitor. 3I Atlas would not stay in the solar system indefinitely. Rather, it was just passing through, moving so rapidly that it would soon leave, continuing its journey out into the depths of space. Yet despite its brief stay in the inner solar system, the object has already made an indelible mark on the scientific community. Its presence in our system offers a rare and valuable opportunity to study an object from another star system up close, a chance that might not come again for many generations. One of the key aspects of studying an object like 3I Atlas is understanding its composition and structure. Though the object is small, measuring only about 150 meters across its surface, has provided valuable clues about its makeup. Early observations revealed that 3I Atlas does not have the typical bright tail or coma associated with comets. This suggests that the object may not be composed primarily of ice and dust as comets are. Instead, its physical properties hint at a more solid composition, potentially a rocky or metallic structure. This observation raises intriguing questions about the makeup of interstellar objects. If 3I Atlas is not a typical comet, what does that mean for other interstellar objects that might be out there traveling between the stars? The absence of a traditional cometary tail has also led to speculation about the object's age and stability. Comets, as they approach the Sun, often lose material in the form of gas and dust, creating the characteristic tails that are visible to telescopes. However, 3I Atlas does not exhibit this behavior, which suggests that it may be much older than typical solar system comets. The object may have been traveling through the galaxy for millions of years, possibly even longer. Its apparent lack of volatile materials could be a sign that it has already lost any ice or gas that might have existed when it was first formed. This raises the possibility that 3I Atlas has been traveling through space for a long time, enduring the harsh conditions of interstellar space without breaking apart or being significantly altered by radiation or other external forces. Scientists have also been keenly interested in the object's motion. As 3I Atlas passed through the solar system, its trajectory seemed to deviate from what would be expected, based solely on gravitational forces. Observations showed that the object was accelerating in a way that could not be fully explained by the sun's gravity. Typically, objects passing through the solar system experience a gravitational slingshot effect, where they are accelerated by the sun's gravity and then continue on their way. However, 3I Atlas's motion suggested that something else might be at play. Could there be non-gravitational forces acting on the object, pushing it in ways that scientists cannot yet fully explain? This deviation in motion has sparked a great deal of speculation. One theory is that 3I Atlas could be experiencing a type of radiation pressure known as the Yarkovsky effect. This phenomenon occurs when a rotating object in space absorbs sunlight and then re-emits the energy as heat, which can create a slight push that affects the object's trajectory. While this effect is typically very small, it might explain some of the unusual acceleration observed in 3I Atlas. However, the strength of the Yarkovsky effect would depend on the object's size, shape, and rotation, and there is still much that remains uncertain about how this could apply to 3I Atlas. Another possibility is that the object's surface could be undergoing sublimation, a process in which material on the object's surface turns directly from a solid to a gas due to the heat of the sun. While 3I Atlas does not have the classic comet tail, it is still possible that it could be shedding material in a way that is not easily visible. This could cause a change in the object's momentum, resulting in the observed acceleration. However, without clear evidence of gas emissions or a visible tail, it remains difficult to confirm this theory. In addition to these theories, some scientists have speculated that the object might be influenced by more exotic forces, such as the presence of dark matter or unknown gravitational interactions. While these ideas remain speculative, they highlight the level of uncertainty surrounding 3I Atlas's behavior. The object's unusual acceleration has made it a focal point for researchers seeking to understand the forces at work in interstellar space. As astronomers continue to track 3I Atlas, the mystery surrounding its origins and motion deepens. The object's arrival has opened up new avenues of research, offering scientists a rare opportunity to study an interstellar visitor in unprecedented detail. Despite the uncertainty about its exact origin and behavior, 3I Atlas has already provided invaluable insights into the dynamics of objects traveling between stars, and it promises to be a subject of study for years to come. As 3I Atlas continues its journey through the solar system, scientists are eager to compare it with objects already known within our own celestial neighborhood. This comparison may help to reveal whether 3I Atlas shares more characteristics with comets' asteroids or entirely new categories of interstellar objects. The most obvious question that arises is whether this object behaves like other solar system bodies, such as comets or asteroids. While it's too early to draw definitive conclusions, there are significant differences that have become apparent, particularly in its motion and physical characteristics. Its apparent lack of a cometary tail, a feature typically associated with comets, suggests that 3I Atlas may not be a regular comet at all. Instead, its physical makeup seems to be closer to that of an asteroid, making it a potential new class of object that straddles the line between comets and asteroids. Comets, when they approach the Sun, typically produce bright, expansive tails as the heat of the Sun causes their icy components to vaporize. This process, known as sublimation, creates a visible coma and tail of gas and dust. 3I Atlas, however, does not exhibit this common characteristic. Instead, its surface remains relatively unchanged, suggesting that it is made of much more stable materials, perhaps similar to an asteroid. This absence of a tail has led to the hypothesis that 3I Atlas is not a typical comet. Instead, it may be composed primarily of rocky or metallic material, with very little ice or volatile gases. The lack of a visible coma and tail could indicate that the object has already shed most of its volatile materials long before entering the solar system, having been exposed to the harsh conditions of space for millions of years. Asteroids are solid objects, composed mainly of metal and rock, which are relatively stable compared to comets. If 3I Atlas is in fact more asteroid-like than comet-like, it could suggest that it was born in a star system vastly different from our own, with conditions that allowed it to retain its solid structure over the course of its journey. This would mean that 3I Atlas is not only an interstellar object, but also a relic from another system, possibly providing clues about the types of objects that form in other star systems. Despite its differences from typical comets, 3I Atlas's behavior still raises some questions that are reminiscent of both cometary and asteroid-like features. For example, its trajectory, which initially suggested a comet-like path, indicates that it is moving rapidly through the solar system and will not be captured by the Sun's gravity. This aspect of its motion is in line with what we expect from cometary bodies, which typically travel through the solar system without becoming permanently bound to the Sun. However, the absence of a visible tail, a hallmark of most comets, is a stark contrast to what scientists would expect from an object following such a path. This has led some researchers to speculate that 3I Atlas may represent a new class of object, one that combines aspects of both comets and asteroids, creating a complex and unique puzzle for scientists to solve. In addition to its physical characteristics, the behavior of 3I Atlas is another area where it differs from typical solar system objects. Observations of 3I Atlas's motion through the solar system have revealed that it is not behaving in a way that can be fully explained by conventional gravitational mechanics. Most objects in the solar system, including asteroids and comets, are governed primarily by gravitational forces, which are relatively easy to model and predict. However, 3I Atlas's motion has shown unexpected acceleration, suggesting that additional forces are at work. This has sparked considerable debate among astronomers, as the object's path does not conform to what we would expect from an object merely passing through the solar system under the influence of the sun's gravity. One possibility is that the object is experiencing a non-gravitational force, such as the Yarkovsky effect. The Yarkovsky effect is a phenomenon that occurs when an object in space absorbs sunlight and re-emits that energy as heat. This heat causes a slight push on the object, which can influence its trajectory over time. However, the Yarkovsky effect typically requires an object to be rotating, and there is still much uncertainty as to whether 3I Atlas's observed acceleration could be explained by this effect alone. While the Yarkovsky effect has been observed in smaller objects within the solar system, its impact on a large object like 3I Atlas is still a matter of debate. Another possibility is that 3I Atlas is shedding material from its surface, a process known as sublimation. Comets experience sublimation when the sun's heat causes volatile materials, such as water ice, to evaporate, creating a tail of gas and dust. Though 3I Atlas does not exhibit a visible tail, it is possible that it is undergoing a similar process on a much smaller scale. If the object is made of solid rock or metal, it may be slowly shedding material in a way that is not easily detectable from Earth. This could lead to a change in the object's momentum, explaining the acceleration observed by scientists. However, without visible evidence of material being ejected, this theory remains speculative, and further observations will be needed to determine whether sublimation is at play. A more radical theory is that 3I Atlas's motion is being influenced by some unknown force or interaction. Some researchers have suggested that the object's acceleration could be the result of interactions with dark matter, a mysterious substance that makes up a significant portion of the universe's mass, but cannot be directly observed. If dark matter interacts with 3I Atlas in some way, it could explain the unexpected changes in its velocity. While this idea is highly speculative, it underscores the level of uncertainty surrounding the object's behavior. The discovery of 3I Atlas has highlighted the many unknowns that still exist in our understanding of space and the forces that govern the motion of objects within it. Despite the uncertainty surrounding 3I Atlas's acceleration, the object remains a critical focus for astronomers. Its unusual motion, along with its ambiguous classification, makes it an invaluable opportunity for study. By continuing to monitor the object's trajectory and collecting data on its composition, scientists hope to gain new insights into the nature of interstellar objects and the forces that influence their movement. As the object moves further away from the solar system, its observations may provide the key to unlocking the mysteries of interstellar travel and the forces that govern the motion of objects between stars. In the years to come, 3I Atlas may help to redefine our understanding of the universe and the objects that inhabit it. Its discovery is just the beginning of a larger exploration into the nature of interstellar objects, and it holds the potential to reveal much about the broader cosmos. As astronomers continue to study 3I Atlas, they are not only learning more about this specific object, but also gaining insights into the larger processes that shape the movement of objects through space. In time, the study of 3I Atlas may change the way we view our place in the universe, revealing the vast interconnected network of objects that exist beyond the boundaries of our solar system. As 3I Atlas continued its passage through the solar system, astronomers closely tracked its path, hoping to glean more information about its origin, trajectory, and behavior. One of the key aspects of understanding 3I Atlas is the study of its motion. While the initial excitement surrounding the discovery of this interstellar object centered on its unique origins, it is the path it takes through the solar system that has kept scientists engaged. The object's high velocity and unusual trajectory, which suggest that it is not bound to the sun's gravity, have raised numerous questions about the forces acting on it. It is moving too quickly to be captured by the sun's gravitational pull, and its course indicates that it is simply passing through the solar system, much like a bullet passing through a target. Understanding this path, then, is essential not only for gaining insight into 3I Atlas itself, but also for understanding the broader dynamics of interstellar objects and their interaction with our solar system. The initial tracking of 3I Atlas began soon after its discovery in October of 2017, with astronomers using telescopes on Earth to plot its trajectory. Early observations showed that the object was moving at an astonishing speed, far higher than any comet or asteroid observed before. It was traveling at a velocity that suggested it was not gravitationally bound to the sun, but instead was simply passing through the solar system on a hyperbolic trajectory. This high speed immediately set it apart from typical solar system objects, which are generally in elliptical orbits bound by the sun's gravity. The speed of 3I Atlas suggested that it had come from far beyond the solar system, likely from a distant star system, though its exact origin remains unknown. By the time 3I Atlas reached the inner solar system in 2017, astronomers had begun to realize just how unique this object was. They tracked its path across the sky with increasing precision, using telescopes in both the northern and southern hemispheres to get the most complete data. The object's rapid movement made it difficult to keep up with, but it was clear that its trajectory was highly unusual. It was not following a simple, predictable orbital path like most objects in the solar system. Instead, it was following an eccentric, elongated path that suggested it had come from a far-off star system. The path of 3I Atlas was mapped with remarkable detail, but it still raised many questions. One of the main mysteries was why the object's trajectory deviated from what would be expected of a simple interstellar object passing through the solar system. According to Newtonian physics, 3I Atlas's motion should have been influenced primarily by the sun's gravity. While gravitational interactions can bend the paths of objects as they pass by the sun, they should not cause an object to accelerate in the way that 3I Atlas did. Observations showed that the object was accelerating even though no known forces should have been capable of doing so. This non-gravitational acceleration has prompted astronomers to look for other explanations. Could the object be experiencing forces that we are only beginning to understand? Or is there something in its composition or structure that could explain its unexpected acceleration? One possibility is that 3I Atlas is being affected by non-gravitational forces, such as radiation pressure from the sun. This is the same phenomenon that influences comets, causing their tails to form as they get closer to the sun. Radiation pressure occurs when sunlight strikes an object, and some of the energy is absorbed or reflected, creating a small push. The amount of radiation pressure that acts on an object depends on its size, reflectivity, and shape. If 3I Atlas is reflecting sunlight in a way that increases its speed, it could explain the observed acceleration. However, this is a relatively small force, and scientists have yet to determine whether it could account for the degree of acceleration observed in 3I Atlas. Another possibility is that the object is shedding material as it passes through the solar system. Though 3I Atlas does not have a visible tail, it is still possible that the object could be losing material in a way that is not immediately apparent. Some researchers have suggested that the object might be undergoing sublimation, a process in which solid materials on the surface of an object change directly into gas. This process is what creates the bright tails of typical comets. However, in the case of 3I Atlas, the absence of a tail makes it difficult to detect whether sublimation is occurring. Still, if the object is losing material, this could lead to a change in its momentum, contributing to its acceleration. This would explain the unusual motion of 3I Atlas, though it raises the question of why the object is not producing the expected cometary features, such as a tail. 3I Dr. Atlas's path has also led some scientists to consider the possibility that it is being influenced by more exotic forces, such as interactions with dark matter. Dark matter is a mysterious substance that makes up a significant portion of the mass of the universe, but cannot be directly detected. If 3I Atlas is somehow interacting with dark matter, this could explain its unexpected motion. However, this theory remains speculative, and there is currently no direct evidence to suggest that dark matter is influencing the object. The discovery of dark matter's role in the motion of interstellar objects would be groundbreaking, but for now it remains a distant possibility. As 3I Atlas continues its journey out of the solar system, astronomers will continue to monitor its trajectory. They will use this data to refine their understanding of its motion and to test the various theories that have been proposed. By studying 3I Atlas in detail, scientists hope to answer some of the fundamental questions surrounding interstellar objects, such as how they move through space and what forces are at work on them. The insights gained from this study will not only help us understand 3I Atlas itself, but could also provide valuable information for the study of other interstellar objects that may be discovered in the future. In the years to come, astronomers expect to track more interstellar objects as they pass through the solar system. These objects, which are thought to come from other star systems, provide a unique opportunity to study materials and structures that are not found within the solar system. If 3I Atlas is indeed the first of many interstellar objects, it could help scientists develop new techniques for studying objects from beyond our solar neighborhood. The study of such objects could reveal much about the nature of interstellar space, the formation of stars and planets, and the dynamics of the galaxy as a whole. The continued observation of 3I Atlas's path and behavior will be essential for understanding the broader implications of this discovery. The object's speed, trajectory, and composition all offer clues to the complex processes that govern the motion of objects across vast interstellar distances. By carefully tracking the movement of 3I Atlas, astronomers hope to unlock the secrets of its origin and the forces that are influencing it as it passes through the solar system. The most intriguing aspect of 3I Atlas's passage through the solar system lies in its unexplained acceleration, which continues to defy current models of celestial mechanics. As the object approached the inner solar system, astronomers noted that its speed was increasing at a rate that could not be accounted for by gravitational forces alone. This unusual behavior raised immediate concerns and led to a deeper investigation into the forces acting on the object. Gravitationally, 3I Atlas should have been subject to the Sun's pull, with its path influenced by the predictable forces of gravity. However, observations showed that its trajectory was not entirely explained by the Sun's gravity, suggesting that additional forces beyond the scope of traditional physics might be at play. In space, objects such as comets typically experience gravitational acceleration as they move closer to the Sun, and their motion is well understood within the framework of Newtonian physics. However, 3I Atlas's motion exhibited anomalies that could not be explained by gravity alone. The object's trajectory deviated from the expected path, and this departure from the norm has been one of the major points of interest for researchers. The object's trajectory was not merely bent or altered in a way that would be expected from a gravitational slingshot effect. Instead, it appeared to be experiencing some kind of additional force that resulted in unexpected changes in its speed. One possibility that astronomers have considered is radiation pressure, a force that occurs when sunlight strikes an object in space. This phenomenon is well known in the study of comets, where the sun's radiation pressure causes gas and dust to be ejected from the comet's surface, creating a visible tail. In the case of 3I Atlas, radiation pressure could be acting on the object in a similar manner, subtly altering its velocity. This process is known as the Yarkovsky effect, where radiation from the sun is absorbed by an object and then re-emitted as heat. The release of heat causes a tiny push in the opposite direction, which can gradually alter the object's course over time. However, this effect alone would not account for the significant acceleration that has been observed. The Yarkovsky effect is generally quite small and typically affects smaller objects such as asteroids over long periods of time. For an object as large as 3I Atlas, it would be expected to have a minimal impact on its motion. In this case, scientists are left wondering whether there is another force at play, one that is far stronger and more complex than what we currently understand. This has led to further speculation about the presence of non-gravitational influences, such as sublimation, or the presence of unknown forces acting on the object. Sublimation, the process in which solid materials turn into gas when heated, is another possible explanation for the acceleration of 3I Atlas. While the object does not display the typical signs of sublimation, such as a visible tail or coma, it is still possible that it could be shedding material in ways that are not immediately apparent. In comets, sublimation is the primary driver of the visible coma and tail as the sun heats the ice on their surfaces, causing it to vaporize and stream away from the object. For 3I Atlas, which is suspected to be made mostly of solid rock or metal, sublimation could still be at play, but on a much more subtle scale. The loss of material could result in an increase in the object's speed as mass is ejected in one direction, causing a slight change in momentum. Despite the lack of visible evidence of gas or dust being expelled, the idea that 3I Atlas could be undergoing sublimation remains plausible. The fact that the object is traveling through the inner solar system means it is exposed to the sun's radiation, which could be affecting its surface in unexpected ways. While the absence of a visible tail suggests that the object may not be releasing significant amounts of gas or dust, it is still possible that it is losing mass in a manner that is not visible to our instruments. If this were the case, it would offer a possible explanation for its accelerated motion. However, the absence of detectable emissions from the object means that any sublimation is likely happening at a much lower level than in typical comets, making it difficult to observe with current technology. As astronomers continue to monitor 3I Atlas's movement, one of the key questions they seek to answer is whether the acceleration observed is consistent over time, or if it changes as the object moves further away from the Sun. The object's path has already taken it past the Sun, and it is now on its way out of the solar system. As it moves further from the Sun's influence, the forces acting on it will change, and its motion may become less affected by radiation pressure or other non-gravitational influences. This could provide astronomers with a clearer picture of what forces are actually at work. If the object's acceleration continues or changes as it moves away from the Sun, it could provide new insights into the nature of the forces influencing 3I Atlas's motion. Another possibility that has been raised in discussions about the object's unusual behavior is that 3I Atlas could be interacting with dark matter. Dark matter is a mysterious substance that is believed to make up a large portion of the mass in the universe, though it cannot be directly observed. It is known to interact with normal matter through gravity, but scientists have yet to determine whether it has any other significant effects on the movement of celestial bodies. If 3I Atlas is experiencing some kind of interaction with dark matter, it could explain the unusual acceleration observed. However, this theory is purely speculative at this point, as there is no concrete evidence to support the idea that dark matter could be influencing the object's path. Nevertheless, the possibility of dark matter playing a role in the object's motion highlights the many unknowns that still exist in our understanding of the forces governing the universe. For now, the study of 3I Atlas's acceleration remains an area of intense interest for astronomers. Its behavior challenges existing models of celestial motion, and the search for an explanation has sparked new theories about the forces that act on interstellar objects. As more data is collected, scientists hope to refine their understanding of the object's motion, and by extension, gain deeper insights into the dynamics of objects traveling between star systems. The discovery of 3I Atlas is a reminder that there is still much to learn about the universe and the objects that inhabit it, and that every new discovery opens the door to even greater questions about the nature of the cosmos. As 3I Atlas moves further through the solar system and away from the Sun, its path continues to offer valuable data for scientists eager to understand its composition and behavior. While much attention has been focused on its trajectory and unusual acceleration, the object's physical characteristics remain a central area of study. Understanding what 3I Atlas is made of is crucial not only for classifying it, but also for gaining deeper insights into the conditions that shaped its formation. The object's appearance or lack of typical cometary features raises questions about the nature of interstellar objects in general and their potential to reveal unknown aspects of space. Unlike comets, which are generally composed of a mixture of ice dust and gas, 3I Atlas does not exhibit the familiar coma or tail that we associate with comets. The absence of a visible tail has been one of the key factors that set 3I Atlas apart from other objects that have passed through the solar system. Comets, as they approach the Sun, warm up and begin to shed material, creating a bright visible tail. This is a direct result of the sun's heat causing volatile substances, such as water and carbon dioxide, to sublimate and stream away from the object. However, 3I Atlas does not exhibit this behavior. Instead, its surface seems to remain largely unchanged, despite its close approach to the Sun, suggesting that it may not be composed of materials that are easily vaporized. The lack of a visible tail suggests that 3I Atlas may be made primarily of solid material, perhaps rock or metal, rather than the ice and dust typically associated with comets. This raises the possibility that 3I Atlas is more akin to an asteroid, or even a new class of interstellar object that blends characteristics of both comets and asteroids. Some scientists have speculated that 3I Atlas is a fragment of a larger body that was broken apart in its home star system, possibly as a result of a collision or other catastrophic event. If this is the case, then 3I Atlas may be a rare example of an interstellar asteroid, an object from another star system composed of rock or metal rather than volatile ices. Despite the lack of a tail, there are still signs that 3I Atlas is interacting with the Sun. As it passes through the inner solar system, the object's surface is exposed to the Sun's radiation, which could be affecting its composition in subtle ways. While no gas or dust has been detected emanating from the object, scientists have observed a faint emission of light from 3I Atlas. This suggests that the object's surface may be undergoing some kind of thermal response to the Sun's heat. One possibility is that the object is absorbing sunlight and re-emitting that energy as heat, which could explain some of the changes in its trajectory and behavior. This process, known as thermal radiation, is a fundamental characteristic of all objects exposed to sunlight. But it may play a more prominent role in the behavior of 3I Atlas due to its high velocity and rapid movement through the solar system. The faint emission of light from 3I Atlas could also suggest that it is not entirely devoid of volatile substances. While the object may not be exhibiting the dramatic sublimation seen in typical comets, it is still possible that it is losing small amounts of material as it passes through the inner solar system. This could be in the form of small gas emissions, or the shedding of dust particles, which may not be detectable by current observation methods. The fact that the object is not losing large amounts of material like a typical comet, however, raises further questions about its composition and stability. It is possible that 3I Atlas is made of material that is much more resilient to the effects of the Sun's heat, allowing it to remain largely intact despite its close approach. In addition to its lack of cometary features, the size and shape of 3I Atlas are also points of interest. The object has been measured to be approximately 150 meters in diameter, which places it in a similar size range to many near-Earth asteroids. While this is small compared to some of the massive comets observed in the solar system, it is still large enough to be detected from Earth. The object's size and shape also make it an excellent target for study. If 3I Atlas is an asteroid-like object, it could offer valuable insights into the types of materials that exist in other star systems. By studying the object's composition, scientists may be able to learn more about the processes that occur during the formation of planetary systems in other parts of the galaxy. The lack of a visible tail combined with the object's size and solid composition suggests that 3I Atlas could be an example of an interstellar object that has already undergone significant changes in its home star system. It may have been subjected to the same kinds of processes that shape asteroids in our own solar system, including impacts and other forms of mechanical stress. However, 3I Atlas's interstellar journey has likely played a role in shaping its current form as well. The object's long journey through space, combined with the extreme conditions of the interstellar medium, could have exposed it to forces that are not typically seen in the solar system. This could have led to the development of its unique characteristics, such as its lack of a visible tail and its apparent lack of volatile materials. The study of 3I Atlas's composition is still in its early stages, but as more data is gathered, scientists will continue to refine their understanding of the object. Understanding what 3I Atlas is made of will not only help scientists classify it, but will also provide critical insights into the conditions that exist in other star systems. If 3I Atlas is indeed composed of solid rock or metal, it could be a unique example of an interstellar asteroid offering a rare glimpse into the building blocks of planetary systems beyond our own. In addition to its scientific value, 3I Atlas also raises broader questions about the nature of interstellar space and the objects that travel through it. While our solar system is relatively quiet and stable, the interstellar medium is far more dynamic. Objects like 3I Atlas are constantly moving through space, passing through different regions of the galaxy and interacting with other star systems. This movement creates a complex web of interactions, and studying objects like 3I Atlas may help scientists understand more about the processes that govern the dynamics of our galaxy. By observing how interstellar objects interact with our solar system, we can gain a better understanding of the forces at play in the universe and the role that objects like 3I Atlas play in the larger cosmic picture. As 3I Atlas continues its journey, scientists will be closely monitoring its path and behavior, hoping to answer the many questions that remain about its composition, motion, and origin. Though much is still uncertain, the study of this interstellar visitor has already provided valuable insights into the nature of objects traveling between stars, and it may continue to do so for years to come. The discovery of 3I Atlas has not only provided scientists with a unique opportunity to study an interstellar object, but has also prompted a re-evaluation of how objects from beyond the solar system might interact with our space environment. As more interstellar objects are likely to be discovered in the future, understanding the behavior of 3I Atlas could provide crucial insights into the dynamics of these objects and how they affect the systems they pass through. One of the most intriguing aspects of 3I Atlas's behavior is the way it seems to defy expectations when it comes to its interaction with the Sun and the solar system's gravity. Its unusual acceleration and the lack of a traditional cometary tail suggest that it may be governed by forces that are not yet fully understood, raising questions about what we know about space dynamics and the influences that guide the movement of objects through the cosmos. The study of 3I Atlas could also shed light on how other objects from distant star systems might behave as they pass through the solar system. The behavior of interstellar objects is an area that has largely been speculative until now. While astronomers have theorized about the existence of interstellar objects, only a handful have actually been detected. The discovery of 3I Atlas marks a turning point in the study of these cosmic wanderers, offering the chance to observe the effects of an interstellar object moving through the inner solar system in real time. If 3I Atlas proves to be an anomaly, it could be a once-in-a-lifetime observation. If it turns out to be representative of other interstellar objects, it could pave the way for an entirely new field of research in planetary science and astronomy. One of the most exciting possibilities for scientists studying 3I Atlas is the potential for discovering other interstellar objects in the future. While 3I Atlas is the first confirmed interstellar object to be observed in such detail, it is likely not the last. As detection methods improve and more observations are made, it's possible that more interstellar objects will be discovered, some of which may be even larger, more complex, or more unique than 3I Atlas. These discoveries could revolutionize our understanding of the universe, shedding light on the diversity of objects that exist beyond the solar system and how they move between stars. The continued study of 3I Atlas could also provide insights into the long-term behavior of interstellar objects. As 3I Atlas moves further away from the Sun, its interactions with the solar system's gravitational field will become less pronounced, and it will begin its journey back into deep space. However, tracking its movement for as long as possible will provide valuable data on how interstellar objects behave once they leave the influence of a star. This information could help scientists understand how such objects travel through space over vast distances, possibly for millions or even billions of years. The fact that 3I Atlas has been able to travel across such a large portion of the galaxy without breaking apart or undergoing significant changes suggests that some objects are far more resilient than previously thought capable of surviving the harsh conditions of space for extended periods. The study of interstellar objects also raises important questions about the processes that govern the formation of planetary systems and star systems. Objects like 3I Atlas could be the remnants of systems that existed long before our own sun and planets formed. They could carry with them valuable information about the early stages of star formation and the conditions that led to the creation of stars, planets, and other celestial bodies. Understanding the composition and structure of these objects could provide insights into the building blocks of planetary systems and help scientists learn more about how the universe's diverse range of star systems came into being. Additionally, the study of 3I Atlas raises the possibility that interstellar objects could play a role in the evolution of our own solar system. While 3I Atlas is not currently on a collision course with Earth, the fact that it passed through the inner solar system raises the question of whether other objects from beyond our solar system could have an impact on our planetary system. Could an interstellar object collide with a planet or asteroid, causing significant changes to the system? While the likelihood of such an event occurring is low, it is not impossible. The discovery of 3I Atlas has opened up new lines of inquiry into the potential interactions between our solar system and interstellar objects, prompting scientists to consider scenarios that had previously been thought to be extremely unlikely. One of the key aspects of studying 3I Atlas is understanding how the object interacts with the space environment of the solar system. While its gravitational interactions with the Sun and planets have been studied in detail, scientists are also interested in its interaction with the solar wind and the interplanetary magnetic field. These interactions can have significant effects on the motion and behavior of objects passing through the solar system, influencing their trajectory and even their physical properties. For example, the solar wind can cause a buildup of charged particles on the surface of an object, potentially affecting its motion or causing it to lose material over time. Understanding these interactions will be important for studying future interstellar objects, as they may behave in ways that are very different from what we observe in the more familiar environment of the solar system. 3I Atlas also raises the possibility that more interstellar objects could be found within the solar system's gravitational influence, traveling through the inner reaches of the system at speeds far greater than typical solar system objects. As our ability to track objects in space improves, it is likely that we will discover other such visitors, further expanding our knowledge of the cosmic neighborhood beyond the solar system. These objects, like 3I Atlas, could provide valuable clues about the dynamics of interstellar space, the forces that influence the movement of objects between stars, and the conditions that exist in other star systems. By studying the composition, motion, and behavior of these objects, scientists may gain a better understanding of the larger processes that govern the universe. The discovery of 3I Atlas has also prompted a re-evaluation of how we approach space exploration. As humanity looks to expand its presence beyond Earth, the study of interstellar objects may provide valuable lessons about the challenges and opportunities of traveling to other star systems. Understanding the dynamics of objects like 3I Atlas could help to inform future missions to explore the outer reaches of our solar system, as well as the broader cosmos. In addition, the discovery of interstellar objects could inspire future missions to investigate these objects directly using spacecraft to gather data and images of these mysterious visitors from other star systems. As 3I Atlas continues its journey through the solar system and into deep space, its study will remain a priority for astronomers. By studying this interstellar visitor, scientists hope to unlock secrets about the nature of interstellar space, the forces that shape the universe, and the origins of objects that traverse between stars. The mystery surrounding 3I Atlas is far from being solved, and each new discovery brings us one step closer to understanding the universe and our place within it. The arrival of 3I Atlas in the solar system has not only deepened our understanding of interstellar objects, but has also sparked debates among scientists about the nature of these mysterious visitors and their potential impact on the solar system. The observation of this object has revealed that interstellar objects are not as rare as once believed, and 3I Atlas's behavior suggests that other similar objects might be out there waiting to be discovered. The study of 3I Atlas offers a unique opportunity to investigate the characteristics of objects that come from other star systems, which could fundamentally alter our understanding of how the universe works and how interstellar objects influence their surroundings. Before the discovery of 3I Atlas, the existence of interstellar objects was largely theoretical. While astronomers suspected that objects might occasionally pass through the solar system, there was no definitive proof of such visitors. The detection of 3I Atlas confirmed that objects from outside our star system do indeed travel through space, and its unusual characteristics have made it the perfect candidate for studying how interstellar objects behave. In many ways, 3i Atlas is the first of its kind, providing an unparalleled opportunity to gather data on an object that has traveled across vast distances of space before entering the solar system. Its arrival is an extraordinary event in the field of astronomy, and scientists are only beginning to scratch the surface of what this discovery means. One of the most significant insights gained from studying 3i Atlas is the realization that objects from other star systems can move through the solar system with little to no interaction with the planets or other bodies. 3i Atlas's high velocity, which has been calculated to be much faster than typical objects within the solar system, suggests that it is not bound by the Sun's gravitational influence. As a result, the object is able to pass through the solar system without becoming gravitationally trapped or significantly altered by the planets. This is a key observation because it shows that interstellar objects do not necessarily have to interact with the gravitational field of the solar system to pass through it. Instead, they can simply pass through the system, continuing on their journey through space without becoming entangled in the solar system's dynamics. This has profound implications for how we view the movement of objects in space, and it challenges our traditional understanding of how gravity and other forces govern the paths of objects. 3i Atlas's behavior also suggests that interstellar objects may not always be as predictable as we once thought. While many objects in the solar system, such as asteroids and comets, follow relatively predictable orbits influenced by the Sun's gravity, 3i Atlas's motion has been characterized by unexpected changes in speed and trajectory. The object's acceleration, which cannot be explained by gravitational forces alone, points to the possibility of other forces at play, such as radiation pressure or sublimation. This acceleration, which has been observed as the object moves through the solar system, may also be related to the object's composition, as the release of gases or materials from its surface could cause a change in its momentum. This complex behavior adds to the mystery of interstellar objects and underscores the challenges scientists face when attempting to understand their motion. Furthermore, the presence of 3i Atlas in the solar system has prompted researchers to think more deeply about the potential for other interstellar objects to pass through our system in the future. While 3i Atlas is the first confirmed interstellar object to be observed, astronomers expect that more will be discovered in the coming years as detection methods improve. The implications of this discovery are far-reaching, as the study of interstellar objects could provide valuable clues about the structure of the galaxy, the processes that govern star and planet formation, and the forces that shape the movement of objects in space. As more interstellar objects are detected and studied, scientists will be able to refine their models of interstellar dynamics, gaining a clearer picture of how objects travel between stars and how they interact with other celestial bodies. One of the primary goals of studying 3i Atlas is to determine whether its unusual acceleration is the result of processes that are common among interstellar objects, or whether it is an anomaly. If the behavior of 3i Atlas is typical of other interstellar objects, it could suggest that forces like radiation pressure and sublimation play a more significant role in shaping the motion of objects than previously thought. On the other hand, if 3i Atlas's behavior is unique, it could indicate that there are other unknown factors at play, potentially leading to the discovery of new physical processes that influence the movement of objects in space. The search for answers to these questions is ongoing, and the discovery of 3-Eye Atlas has opened up a new frontier in the study of interstellar objects. In addition to the insights gained from 3-Eye Atlas's motion and composition, the object's presence in the solar system also raises questions about the potential for interstellar objects to impact the planets or other bodies within the system. While 3-Eye Atlas's passage did not result in any catastrophic events, the idea that other interstellar objects could collide with planets or asteroids is a topic of concern for astronomers. Though the likelihood of a direct impact with Earth or any other planet in the solar system is extremely low, the fact that objects from outside our star system can enter the system raises the possibility of future collisions with planets, moons, or other bodies. Such events could have significant consequences, and it is essential for scientists to monitor the movement of interstellar objects as they travel through the solar system. The study of 3-Eye Atlas has highlighted the need for continued observation of these objects to better understand the risks they might pose and to develop strategies for dealing with potential impacts. The discovery of 3-Eye Atlas has also prompted a re-evaluation of the broader implications of interstellar exploration. If objects like 3-Eye Atlas are capable of traveling across vast distances of space, it suggests that interstellar travel may be more feasible than previously believed. While 3-Eye Atlas is not a spacecraft, its journey through the solar system has highlighted the potential for objects to move between stars over long periods of time. This has led some scientists to speculate about the possibilities for future interstellar missions, whether they be robotic probes or in the distant future manned spacecraft. The study of 3-Eye Atlas could provide valuable lessons about the challenges and opportunities of traveling between stars, offering insights into the long-term dynamics of space travel and the forces that govern movement across the vast distances of the galaxy. As 3-Eye Atlas moves further away from the solar system, the opportunity to study this object will soon be over, but its legacy will live on. The data collected from its passage through the solar system will continue to be analyzed for years to come, contributing to our understanding of interstellar objects and their behavior. The study of 3-Eye Atlas has opened up a new chapter in our exploration of the universe, revealing the vast and complex nature of space beyond the solar system. The discovery of this object has not only provided new knowledge about interstellar objects, but has also paved the way for future discoveries that may further change our understanding of the cosmos. As 3-Eye Atlas continues to move through the solar system on its way out into the depths of space, the significance of its discovery becomes clearer with each passing day. The object's unusual features and behavior have prompted scientists to think more critically about the forces that shape the motion of interstellar objects and their interaction with the solar system. With its unexpected acceleration, lack of a visible tail, and unusual composition, 3-Eye Atlas has sparked new avenues of research and raised important questions about the nature of objects traveling between stars. The continued study of 3-Eye Atlas has the potential to reveal far-reaching insights into the dynamics of space and the forces that govern the movement of objects across vast interstellar distances. One of the central mysteries surrounding 3-Eye Atlas is its acceleration. The object's motion has been observed to deviate from the expected path, with its speed increasing in a way that cannot be fully explained by gravitational forces alone. This has led to the hypothesis that 3I Atlas is being influenced by non-gravitational forces, such as radiation pressure or sublimation. However, while these forces are known to affect comets and other objects, their impact on a large solid body like 3I Atlas is less understood. As scientists continue to monitor the object's motion, they are gathering valuable data on the behavior of interstellar objects, and this information could help refine our understanding of how such objects interact with the forces of gravity, light, and heat. The lack of a visible tail is another key feature of 3I Atlas that sets it apart from typical comets. Most comets, as they approach the Sun, shed material from their surfaces, creating a tail of gas and dust. This process, known as sublimation, occurs when the Sun's heat causes volatile materials to vaporize and stream away from the object. However, 3I Atlas does not exhibit this behavior. Instead, its surface appears to remain largely unchanged, despite its close approach to the Sun. This has led scientists to speculate that 3I Atlas may be composed of solid rock or metal rather than the ice and gas typically found in comets. The absence of a visible tail suggests that the object is far more stable and resilient than a typical comet, possibly due to its composition or its long journey through space. This raises important questions about the materials that make up interstellar objects and whether they differ from the objects we encounter within the solar system. In addition to the lack of a visible tail, 3I Atlas's size and shape have provided important clues about its nature. Measuring approximately 150 meters in diameter, 3I Atlas is relatively small compared to some of the largest comets and asteroids in the solar system. Its size places it within the range of near-Earth asteroids, which are objects that come close to Earth's orbit, but do not collide with the planet. The object's small size makes it an ideal target for study, as it offers a snapshot of an interstellar object that has survived the harsh conditions of space for millions or even billions of years. If 3I Atlas is an asteroid-like object, it could provide valuable insights into the formation of rocky bodies in other star systems and how they might differ from the asteroids in our own solar system. While the object's composition remains a subject of ongoing investigation, its journey through the solar system offers important lessons about the long-term dynamics of interstellar travel. As 3I Atlas continues its journey away from the Sun, it will gradually move beyond the reach of the solar system's gravitational field. This will allow scientists to study how objects like 3I Atlas behave once they leave the influence of a star. By observing the object's motion as it moves further into deep space, astronomers can gain a better understanding of how interstellar objects travel across vast distances. The fact that 3I Atlas has been able to survive its long journey through the galaxy without breaking apart or undergoing significant changes suggests that some interstellar objects are far more resilient than previously believed. One of the key aspects of studying 3I Atlas is understanding how objects from other star systems might interact with our solar system. The discovery of this interstellar visitor has shown that the solar system is not an isolated system, but rather one that is part of a much larger interconnected universe. Interstellar objects like 3I Atlas are constantly moving through the galaxy, passing between stars and star systems. While the likelihood of direct collisions with planets or moons is low, the presence of objects like 3I Atlas raises important questions about how such objects might affect the solar system over time. The potential for future interactions with interstellar objects is something that scientists will need to consider as they monitor the movement of other objects from beyond our star system. One of the most exciting possibilities raised by the study of 3I Atlas is the potential for future missions to explore interstellar objects directly. While 3I Atlas itself is not a spacecraft, its passage through the solar system has sparked renewed interest in the idea of interstellar exploration. The study of interstellar objects like 3I Atlas could provide valuable information about the conditions that exist beyond the solar system and the challenges that future missions might face as they travel between stars. The possibility of sending spacecraft to explore interstellar objects is still a distant goal, but the study of 3I Atlas is a step in that direction. By observing how interstellar objects behave and how they interact with the solar system, scientists can begin to lay the groundwork for future missions to explore the farthest reaches of space. 3I or Atlas also raises important questions about the potential for life beyond Earth. While there is no evidence to suggest that 3I Atlas is anything more than a rocky object, the fact that it has traveled across such vast distances of space without breaking apart suggests that interstellar objects may have the potential to survive in environments that are inhospitable to life as we know it. This raises the possibility that objects like 3I Atlas could be carriers of organic materials or other substances that might support life. The idea that interstellar objects could potentially carry the building blocks of life across the galaxy has implications for our understanding of life beyond Earth and the potential for life to exist elsewhere in the universe. As 3I Atlas continues its journey through the solar system and beyond, it will undoubtedly remain a key focus for astronomers and planetary scientists. The data collected from its passage through the solar system will continue to provide valuable insights into the behavior of interstellar objects and the dynamics of space. Whether 3I Atlas is an anomaly or part of a larger class of interstellar objects, its discovery marks a pivotal moment in the study of the cosmos. As more objects from beyond the solar system are discovered, scientists will continue to explore the many mysteries that 3I Atlas has raised and seek to understand the broader implications of interstellar travel and the forces that govern the motion of objects across the universe. As 3I Atlas moves further from the Sun, the observations of its motion and behavior continue to provide valuable data. But they also highlight the many uncertainties that remain about interstellar objects and their interaction with our solar system. The rapid passage of 3I Atlas through the solar system is a reminder of the dynamic and ever-changing nature of space. While astronomers have been able to gather a wealth of information about the object, many questions remain unanswered, particularly regarding the forces that are affecting its motion. The acceleration of 3I Atlas, which cannot be explained by gravity alone, suggests that the object is being influenced by additional, as yet unknown forces. Understanding these forces is one of the key challenges for scientists as they continue to track 3I Atlas and other interstellar objects that may pass through the solar system in the future. In the case of 3I Atlas, the observed acceleration has sparked several theories, but no single explanation has been universally accepted. Radiation pressure from the Sun, which acts on objects as they pass through the solar system, is one possible explanation. However, this effect is typically small, and its influence on larger objects like 3I Atlas is thought to be minimal. The idea that 3I Atlas is undergoing sublimation, where material from its surface is turning into gas due to the Sun's heat, is another possibility. While this is a common feature of comets, it is not as apparent in 3I Atlas, which has shown no visible tail. Even so, it remains plausible that the object is slowly shedding material, and that this process is contributing to its acceleration. Some researchers have gone further and speculated that the motion of 3I Atlas could be the result of interactions with dark matter, a mysterious and invisible substance that is believed to make up most of the universe's mass. While this theory is highly speculative and lacks concrete evidence, it highlights the many unknowns that remain about the forces at play when objects pass through the solar system. The idea that 3I Atlas's motion could be influenced by dark matter or other unknown factors underscores the need for further study of interstellar objects and their behavior. If new forces are at work, they could completely change our understanding of the physics governing objects in space. The discovery of 3I Atlas also raises broader questions about the nature of interstellar objects and their potential to shape the evolution of planetary systems. Objects like 3I Atlas travel vast distances across space, often originating in other star systems, and their passage through our solar system provides a unique opportunity to study the processes that govern the formation and movement of objects in the galaxy. It is possible that over the course of the history of the universe, interstellar objects like 3I Atlas have had a significant impact on the development of planetary systems. For example, they could have been responsible for delivering key materials, such as water or organic molecules, to young planets, potentially playing a role in the origins of life. This idea, known as panspermia, suggests that life on Earth or elsewhere in the galaxy could have been seeded by objects traveling between stars. The idea that interstellar objects may have been responsible for delivering the building blocks of life is still speculative, but it opens up a host of exciting possibilities for the future study of interstellar objects. As 3I Atlas continues its journey, scientists will continue to look for signs that could confirm or disprove this hypothesis. The detection of organic molecules or other life-related materials on 3I Atlas would be groundbreaking, but it is also unlikely that such discoveries will be made given the object's current trajectory and the limited time it will spend in the solar system. Nevertheless, the fact that 3I Atlas is the first confirmed interstellar object to pass through the solar system provides an unparalleled opportunity to study the characteristics of objects that travel between stars. The future study of these objects could reveal new insights into the origins of life in the universe. The impact of 3I Atlas on our understanding of interstellar space extends beyond the search for life. The discovery of this object has prompted a reassessment of how we view the space between stars. Until now, space beyond the solar system was thought to be relatively empty, with objects traveling through it on long, slow journeys. However, the discovery of 3I Atlas has shown that interstellar space is far more dynamic than previously imagined. Objects like 3I Atlas are not isolated. They are part of a broader, interconnected network of matter that stretches across the galaxy. As more interstellar objects are discovered, scientists will be able to study how these objects interact with the interstellar medium, the region of space between stars that contains gas dust and other matter. This research could provide a better understanding of the structure and composition of interstellar space itself. In addition to the scientific value of studying 3I Atlas, the object's passage through the solar system raises important questions about the potential for future interactions with interstellar objects. While the likelihood of a direct impact with Earth or another planet is low, the passage of 3I Atlas through the solar system serves as a reminder that objects from beyond our star system are capable of entering the inner reaches of the solar system. The fact that 3I Atlas passed through the solar system without any significant disruption is fortunate, but future interstellar objects may not be so benign. While the chances of a catastrophic collision are remote, the possibility of smaller impacts with asteroids, comets, or even planets cannot be ruled out. As more interstellar objects are discovered, scientists will need to develop strategies to monitor these objects and assess any potential risks they may pose to Earth and the rest of the solar system. The study of 3I Atlas also highlights the importance of developing better detection methods for interstellar objects. As telescopes become more powerful and new methods for tracking objects in space are developed, astronomers will be able to discover and study more objects that come from beyond the solar system. The discovery of 3I Atlas has opened the door to a new field of study in astronomy, and it is likely that more interstellar objects will be detected in the coming years. Each new discovery will provide more data for scientists to analyze and will help refine our understanding of the dynamics of interstellar objects and their role in the broader universe. As we continue to study 3I Atlas and other interstellar objects, we may find that the universe is far more interconnected and dynamic than we ever imagined. In the long term, the study of interstellar objects could have profound implications for the future of space exploration. If we are able to learn more about the characteristics of these objects, we may one day be able to use them to our advantage. For example, future missions to explore the outer reaches of the solar system, or even interstellar space, could benefit from the knowledge gained from studying objects like 3I Atlas. Understanding how interstellar objects travel through space and how they interact with the solar system could inform the design of spacecraft capable of exploring the distant reaches of our galaxy. As humanity looks toward the stars, the study of interstellar objects like 3I Atlas will likely play a central role in our understanding of the universe and our place within it. As 3I Atlas continues its journey beyond the solar system, its passage provides an opportunity to reflect on the larger implications of its discovery and what it means for our understanding of space-time and the universe itself. The object's origins, trajectory, and behavior all raise fundamental questions about the nature of interstellar space and how objects move between stars. Its unexpected acceleration, combined with its unusual composition and lack of visible features typically associated with comets, has challenged long-held assumptions about how celestial bodies behave. The continued study of 3I Atlas, along with the lessons it teaches us, will shape future astronomical research and our broader understanding of the cosmos. The lack of a typical cometary tail in 3I Atlas is a particularly intriguing aspect of its behavior. As discussed earlier, Comets usually exhibit bright tails created by the sublimation of ices as they approach the Sun, but 3I Atlas shows no such features. Its surface appears solid with minimal signs of gas or dust being released. This absence of a tail suggests that 3I Atlas may not be composed primarily of volatile substances like typical comets. Instead, it may be composed of rock or metal, which are far more stable under the intense radiation of the Sun. The lack of a visible coma or tail means that 3I Atlas does not exhibit the typical processes we associate with comets, making it an anomaly in the study of interstellar objects. The question of what 3I Atlas is made of remains unanswered, but the object's composition holds important clues about its origin and the environment from which it came. If the object is composed of rock or metal, it may offer insights into the formation of planetary bodies in other star systems. Unlike comets, which are thought to originate from the colder outer regions of a star system, 3I Atlas's composition suggests it may have formed in a region closer to its home star, where materials like rock and metal are more abundant. This would make 3I Atlas more similar to an asteroid than a comet, raising questions about how objects from different star systems are formed and what factors contribute to their composition. Moreover, the discovery of 3I Atlas has underscored the complexity of the interstellar medium, the vast expanse of gas and dust that exists between stars. Interstellar space was once thought to be a mostly empty region of space, but observations of 3I Atlas and other objects have revealed that it is far more dynamic. The path of 3I Atlas through the interstellar medium shows that objects can travel vast distances between stars, crossing through a region of space that is not as empty as once thought. In fact, the interstellar medium is home to a variety of gas, dust, and radiation that can have significant effects on the motion and composition of interstellar objects. Understanding how 3I Atlas interacted with this environment is key to understanding how objects from other star systems move through the galaxy. The study of 3I Atlas has also led to broader discussions about the potential for other interstellar objects to pass through the solar system. The idea that more interstellar objects could be discovered in the future has prompted scientists to refine their methods for detecting and tracking such objects. Currently, only a handful of interstellar objects have been identified, but as technology improves, astronomers expect to detect more of these visitors from beyond the solar system. This has the potential to open up a new frontier in the study of the cosmos, with the discovery of interstellar objects offering unique insights into the formation of stars and planets, as well as the movement of objects across vast distances of space. In addition to studying the physical properties of objects like 3I Atlas, scientists are also interested in the potential for these objects to shed light on the dynamics of space travel. As interstellar objects pass through the solar system, they offer a glimpse into the mechanics of movement between stars. The discovery of 3I Atlas raises the possibility that objects from other star systems could be more common than previously thought, and their study could provide valuable data for future space missions. As humanity looks toward the possibility of interstellar exploration, the study of interstellar objects like 3I Atlas could inform the design of spacecraft and propulsion systems capable of traveling between stars. One of the most exciting prospects of studying 3I Atlas is the potential to learn more about the origins of life. While there is no direct evidence linking 3I Atlas to the origins of life, the possibility that interstellar objects could carry the building blocks of life between stars is an intriguing one. Some theories suggest that organic molecules or even microbial life could be transported on the surfaces of interstellar objects, traveling across the galaxy and potentially seeding life on other planets. While it is too early to say whether 3I Atlas carries any life-related materials, its passage through the solar system has prompted scientists to reconsider the possibility that life could exist beyond Earth, and that objects like 3I Atlas could play a role in the transfer of life's building blocks across the galaxy. The discovery of 3I Atlas has also prompted discussions about the potential risks posed by interstellar objects. While the likelihood of a direct collision with Earth is remote, the passage of 3I Atlas through the solar system serves as a reminder that objects from outside the solar system can enter the system with little warning. The potential for such objects to impact Earth or other planets, while unlikely, cannot be entirely ruled out. In the case of 3I Atlas, its speed and trajectory ensured that it did not collide with any planet or moon, but future interstellar objects may not be so fortunate. The study of interstellar objects and the monitoring of their paths through the solar system will become increasingly important as more objects are discovered. As 3I Atlas moves further away from the solar system, its study will continue to yield valuable data, but the object will eventually become too distant to observe directly. Nevertheless, the legacy of 3I Atlas will endure, as the knowledge gained from studying this interstellar visitor will continue to shape future research in astronomy, planetary science, and space exploration. The discovery of 3I Atlas marks a significant milestone in our understanding of the universe and the objects that exist within it, and it has opened up a wealth of new avenues for exploration and discovery. In the coming years, 3I Atlas will likely be remembered not only for its unusual behavior, but also for its role in opening a new chapter in our understanding of interstellar space. As more interstellar objects are discovered, we will continue to study these cosmic wanderers to gain a deeper understanding of the forces that shape the movement of objects between stars, the conditions that govern the formation of star systems, and the potential for life to exist beyond Earth. The discovery of 3I Atlas has already had a profound impact on our understanding of the universe, and its study will continue to inspire and inform scientific inquiry for many years to come. The continued passage of 3I Atlas through the solar system brings with it a deeper understanding of the dynamic nature of space. As it moves further from the Sun, the object's journey is not just a one-time event of scientific discovery. It has created an enduring opportunity for the astronomical community to rethink its approach to interstellar exploration. The sheer scale of the object's journey through the vastness of space raises important questions about the conditions that govern movement between stars. As 3I Atlas exits the solar system, we are reminded that it represents only one of many such objects that have traveled the galaxy for billions of years. Its arrival in our solar neighborhood is a rare event. Yet it offers a glimpse into the broader universe of objects that we have only begun to understand. 3I Atlas's passage emphasizes the importance of recognizing interstellar objects not as isolated anomalies, but as part of a larger, constant flow of matter moving across the galaxy. The idea that objects from other star systems occasionally pass through our solar system is no longer a theoretical concept. It is now a confirmed reality. As the first interstellar object to be definitively observed, 3I Atlas has provided critical data on the nature of interstellar space and the objects that travel through it. With the increasing ability of astronomers to detect objects traveling through the solar system, future discoveries of interstellar visitors are expected to become more frequent, transforming how we study the universe. It is possible that we are witnessing the beginning of a new era in astronomy, one in which the study of interstellar objects becomes just as integral as studying objects within the solar system. The ongoing research into the nature of 3I Atlas also reveals how our understanding of space is still evolving. While we have long known that stars are separated by vast distances, the idea that objects might be freely moving between these stars, crossing unimaginable stretches of interstellar space, opens new possibilities for how we think about the structure and behavior of the galaxy. The fact that 3I Atlas has survived a journey through such a hostile environment without breaking apart or losing significant material is remarkable. The object has shown resilience enduring the pressures of cosmic radiation dust and the gravitational forces of countless stars as it moved through the interstellar medium. This adds another layer of complexity to the study of interstellar space and raises questions about how objects in the galaxy interact with the forces surrounding them. The future of interstellar object research is intrinsically tied to the methods we use to detect these objects. 3I Atlas's detection was a significant achievement made possible by advancements in astronomical technology. The Atlas survey designed to monitor near-Earth objects was responsible for identifying the object as it passed through the solar system. The methods used in this detection process, combined with ongoing technological improvements in telescopes and tracking systems, are likely to lead to more discoveries in the years to come. The lessons learned from studying 3I Atlas will shape the tools and techniques astronomers use to study interstellar objects, improving our ability to track their movement and study their composition. This enhanced capability will make it easier to spot future interstellar visitors, which could lead to even greater discoveries about the nature of objects that travel between stars. The continued observation of 3I Atlas's trajectory and the collection of additional data will also help refine our understanding of the forces that influence its motion. While some hypotheses such as radiation pressure or sublimation have been put forward to explain the object's unexpected acceleration, the true cause remains unclear. The unique motion of 3I Atlas may be a combination of multiple factors, or it may involve a new phenomenon that has yet to be fully understood. This complexity underscores the need for continued research and the development of new theories in celestial mechanics. If future interstellar objects exhibit similar behaviors, it would confirm that our understanding of gravitational forces, radiation pressure, and other physical influences on objects in space may require fundamental updates. The study of 3I Atlas thus represents not only the investigation of a singular object, but also an opportunity to challenge and refine our broader models of space physics. In addition to its scientific value, 3I Atlas's discovery has prompted philosophical and practical considerations about how humanity should approach the study of interstellar space. The object's passage through the solar system offers an opportunity to reflect on the ways in which interstellar objects could affect future space exploration. As we look toward the possibility of exploring other star systems, it is clear that objects like 3I Atlas could hold important information about the conditions that exist in other parts of the galaxy. If humanity is to send missions beyond the solar system studying the movement of interstellar objects, could help inform future spacecraft design, navigation strategies, and mission planning. Interstellar objects like 3I Atlas could serve as natural stepping stones for future missions, helping to guide spacecraft toward new frontiers. Furthermore, the study of 3I Atlas and other interstellar objects may eventually have implications for understanding the origins of life itself. The idea that organic molecules could be transported across the galaxy by objects like 3I Atlas is a tantalizing possibility, one that is still being explored by scientists. While there is currently no evidence to suggest that 3I Atlas is carrying life-related molecules, its study raises the possibility that interstellar objects could act as carriers of life's building blocks, potentially contributing to the development of life on other planets. This idea, known as panspermia, suggests that life may not have originated solely on Earth, but may have been seeded from other parts of the galaxy. While the connection between interstellar objects and the origins of life remains speculative, it is an intriguing concept that adds another layer of mystery to the study of 3I Atlas and similar objects. In the long term, the discovery of 3I Atlas could also influence our search for extraterrestrial life. As our understanding of interstellar objects grows, so too does our understanding of the broader possibilities for life in the universe. The idea that life could be spread across stars by interstellar objects expands our view of how life might exist beyond Earth. The study of objects like 3I Atlas could help us refine our search for habitable exoplanets, as well as guide future efforts to detect signs of life elsewhere in the galaxy. If interstellar objects can carry the basic ingredients for life, it suggests that life may be more widespread than we currently imagine. The study of 3I Atlas has already provided valuable insights into the nature of objects from other star systems, and the data collected will continue to shape our understanding of interstellar space for years to come. As astronomers continue to monitor the object's path and analyze its behavior, they will not only uncover more about this particular object, but will also refine their methods for studying future interstellar visitors. The legacy of 3I Atlas, both in terms of the knowledge it provides and the inspiration it offers for future research, will extend far beyond its brief passage through the solar system. With each new interstellar object discovered, we continue to expand our view of the universe and our place within it, driven by the desire to understand the forces and mysteries that shape the cosmos. As the study of 3I Atlas progresses, the object's passage through the solar system continues to reveal more about the broader context of interstellar objects and the dynamic nature of space. The object's unique characteristics challenge the models and assumptions we have long used to understand the movement of celestial bodies, and its behavior adds new layers of complexity to our understanding of interstellar travel. By analyzing its trajectory, composition, and acceleration, scientists have begun to explore the forces that shape the movement of interstellar objects, but many aspects of its behavior remain shrouded in mystery. This ongoing research offers an opportunity to expand the boundaries of astronomical knowledge and refine the tools and methods used to study distant objects, whether they come from within the solar system or beyond it. One of the key challenges in studying interstellar objects like 3I Atlas is the limited time during which they are observable. As 3I Atlas continues its path away from the solar system, the object will become more difficult to track and study. Yet the data that has already been gathered provides an invaluable snapshot of an object passing through our star system from a distant region of the galaxy. The uniqueness of 3I Atlas lies in its ability to offer scientists a first-hand look at an object from outside our solar system, a rare opportunity that will not soon be replicated. Its brief stay within the solar system has allowed astronomers to analyze its motion track, its changes in speed and direction, and explore its physical composition. As the object moves further out into space, the challenge will be to continue analyzing it from a distance, using advanced technology to monitor any changes and refine the models that explain its behavior. The short duration of 3I Atlas's visit also highlights the need for improved observation techniques. As interstellar objects become a more significant focus for astronomers, the development of better detection methods will be crucial for capturing data on these fleeting visitors. While the detection of 3I Atlas was a major achievement, it was only by chance that this particular object was spotted. The existing technology for tracking objects that come from outside the solar system is still in its early stages, and many objects may go unnoticed or be too distant to study in detail. The possibility of future discoveries of interstellar objects, whether similar in size and composition to 3I Atlas or vastly different, depends on advances in technology that allow astronomers to spot these objects earlier in their journey through the solar system. The future of interstellar object detection will depend on our ability to improve telescope sensitivity, refine tracking algorithms, and develop more comprehensive sky surveys that can identify objects passing through the solar system before they exit the observational range. Despite these challenges, the discovery of 3I Atlas has already influenced how scientists think about the movement of objects in space. The object's speed trajectory and unexpected acceleration suggest that the forces acting on it are far more complex than originally anticipated. The study of 3I Atlas has underscored the fact that the universe is not as predictable as we might have assumed. Even objects that seemed simple at first glance, like a small asteroid or comet, can exhibit behaviors that defy our understanding of physics. The acceleration of 3I Atlas, which cannot be fully explained by gravitational forces alone, has forced scientists to think beyond traditional models of motion and consider new possibilities. This has led to the exploration of non-gravitational forces, such as radiation pressure, or the potential for sublimation, as well as more speculative theories about dark matter and unknown forces. The study of 3I Atlas has also raised important questions about the stability of interstellar objects over time. While the object has remained intact during its journey through the solar system, it has traveled across vast stretches of space that are often harsh and unforgiving. The interstellar medium, which consists of gas and dust, can have an impact on objects as they move through it, slowly eroding their surfaces or causing them to lose material. Yet 3I Atlas has shown remarkable resilience, suggesting that some interstellar objects are capable of surviving for long periods of time in the harsh environment of interstellar space. The object's ability to retain its shape and composition over millions of years offers new insights into the materials that make up objects in other star systems. This raises questions about whether other interstellar objects might be just as resilient, or whether they are subject to processes that could cause them to break apart or undergo dramatic changes over time. The continued study of 3I Atlas and similar objects also provides a glimpse into the larger structure of the galaxy and the dynamics of star systems. As 3I Atlas moves through the solar system, it is a reminder that we are not alone in our star system. Objects from other star systems are constantly moving through interstellar space, passing through different regions of the galaxy and occasionally entering our solar neighborhood. The idea that objects are moving between stars in a cosmic web of motion challenges the traditional view of the solar system as an isolated entity. Instead, the study of interstellar objects emphasizes the interconnectedness of the galaxy, where objects from one star system can traverse vast distances and end up in another. The discovery of 3I Atlas serves as a reminder of the broader cosmic context in which our solar system exists, highlighting the dynamic and ever-changing nature of the universe. This interconnectedness also prompts us to rethink the long-term evolution of planetary systems. If interstellar objects like 3I Atlas can travel through the galaxy and pass through star systems, they may have a profound impact on the development of planetary systems. While the chances of a direct collision with a planet are low, the passage of interstellar objects could influence the trajectory of other objects within the solar system. The gravitational forces of interstellar visitors could perturb the orbits of asteroids or comets, potentially redirecting them toward planets or causing changes in the behavior of other objects. The study of interstellar objects is therefore not only important for understanding these specific visitors, but also for examining the broader mechanisms that govern the movement of objects within the solar system and beyond. As 3I Atlas continues its journey, scientists will continue to monitor its path and analyze its composition. With each new observation, they will refine their understanding of the forces acting on the object and the characteristics that define interstellar objects. This ongoing study will shape the future of astronomical research as scientists build on the discoveries made from studying 3I Atlas and apply this knowledge to future interstellar objects. As technology improves and detection methods become more refined, we can expect more interstellar objects to be discovered, each one offering new insights into the mysteries of the universe. The discovery of 3I Atlas has opened up a wealth of possibilities for further exploration. As we continue to study this unique object, we are not only learning more about 3I Atlas itself, but also about the broader processes that govern the motion of objects through space. The lessons learned from studying 3I Atlas will continue to shape our understanding of the universe, revealing the complexities and wonders of interstellar space that were once beyond our reach. The final stages of 3I Atlas's journey through the solar system serve not only as an end to its passage through our star system, but as a pivotal moment for scientific exploration and discovery. While its time within the solar system has been brief, the data gathered from its trajectory, behavior, and composition will continue to shape our understanding of the forces that govern space for years to come. As 3i Atlas moves out of the reach of Earth-based telescopes, the opportunity to study this unique object in detail will soon diminish. But the knowledge gained from its passage will leave an indelible mark on the field of astronomy. One of the key lessons learned from 3i Atlas's visit is the realization that interstellar objects are far more common than previously thought. Before 3i Atlas, the idea that objects from outside the solar system could pass through our space was a matter of theoretical speculation. The discovery of this object and its confirmed interstellar origins has changed the way scientists view the universe. It suggests that interstellar objects could be a regular part of the galactic landscape, and that our solar system may occasionally play host to other interstellar visitors. With this in mind, the detection of future interstellar objects will likely become a central focus for astronomers with new methods and technologies designed to detect and track objects like 3i Atlas in real time. As the search for more interstellar objects continues, it is likely that we will discover a variety of objects with different characteristics, compositions, and behaviors. Some may resemble 3i Atlas, while others may be entirely different in their properties. This growing body of knowledge will allow astronomers to build a more comprehensive understanding of the diversity of objects in the universe and how they move through space. By studying objects that have traveled across vast distances between stars, we can gain valuable insights into the dynamics of star systems, the processes of object formation, and the interactions between different regions of the galaxy. The discovery of 3i Atlas has also prompted a reassessment of the solar system's role within the broader galaxy. While we have long viewed our star system as a relatively isolated system, 3i Atlas's passage has shown that it is part of a much larger cosmic network. Interstellar objects such as 3i Atlas do not adhere to the predictable paths of objects within the solar system, and their passage through our space is a reminder that we are not isolated from the rest of the galaxy. The universe is filled with objects that move freely between stars, and our solar system is just one of many star systems in a vast cosmic web. This realization expands our view of space and highlights the importance of studying the movement and behavior of interstellar objects. As we continue to track 3i Atlas's departure from the solar system, scientists will focus on refining our understanding of the forces that influence its motion. While gravitational forces from the Sun have been the primary influence on objects within the solar system, 3i Atlas has shown that other forces such as radiation pressure or sublimation can play a significant role in shaping the behavior of interstellar objects. The acceleration of 3i Atlas, which cannot be fully explained by gravity alone, has spurred scientists to explore new theories and develop models that account for the complex interactions between objects from different star systems and the forces at work in interstellar space. This research into the forces affecting interstellar objects will help refine our understanding of space physics and celestial mechanics. As we study more objects from outside our solar system, we will develop a better understanding of the fundamental processes that govern the motion of objects in space. Whether the forces at play are known ones, such as radiation pressure or sublimation, or entirely new forces that we have yet to discover, studying the movement of interstellar objects will undoubtedly lead to new insights into the workings of the universe. Each new discovery brings us closer to understanding the larger forces that shape the cosmos, and Three-Eye Atlas's passage has been an invaluable step in that direction. The study of interstellar objects like Three-Eye Atlas also holds implications for future space exploration. As humanity looks toward sending probes and spacecraft to other star systems, understanding the behavior of objects that move between stars will be essential. The study of interstellar objects could help inform the design of future spacecraft navigation systems and propulsion technologies. For example, understanding the speed trajectory and potential for acceleration of objects like Three-Eye Atlas could help scientists plan future interstellar missions, ensuring that spacecraft are prepared to navigate the complexities of interstellar space. The insights gained from studying Three-Eye Atlas will also help refine our understanding of how spacecraft could be influenced by the same forces that affect interstellar objects, whether it be radiation pressure or other interactions with the environment of deep space. One of the most profound implications of the discovery of Three-Eye Atlas is its potential to inform the search for life beyond Earth. While there is currently no direct evidence linking Three-Eye Atlas to the origins of life, its passage through the solar system has raised questions about how life could be spread across the galaxy. The idea of panspermia, the hypothesis that life or its building blocks could be transported by objects from one star system to another, is an intriguing possibility. While the search for life-related molecules or signs of life on Three-Eye Atlas itself is ongoing, the fact that interstellar objects like it may carry organic molecules or other substances across vast distances of space has profound implications for the search for extraterrestrial life. If life or its precursors can be transported in this way, it suggests that life may be more widespread in the universe than previously thought. The study of Three-Eye Atlas and other interstellar objects could ultimately help answer some of the most fundamental questions about the nature of life in the universe. If interstellar objects can indeed carry the building blocks of life between stars, it opens up the possibility that life on Earth and potentially on other planets could have been seeded from elsewhere in the galaxy. This concept, though speculative, offers a tantalizing possibility for how life may have originated and spread across the cosmos. The study of Three-Eye Atlas serves as a reminder that the universe is vast and interconnected, and that life may not be confined to a single planet or star system, but could be part of a much larger cosmic process. In conclusion, the discovery and study of Three-Eye Atlas has provided invaluable insights into the nature of interstellar objects and the forces that govern their motion. While much remains to be learned about this enigmatic visitor from another star system, the data collected during its passage through the solar system has already reshaped our understanding of interstellar space and opened up new possibilities for future research. As astronomers continue to track Three-Eye Atlas's path and analyze its behavior, they will uncover more details about the forces at work in the universe and how interstellar objects travel across the vast distances between stars. The legacy of Three-Eye Atlas will continue to inspire scientific inquiry for years to come, and it will undoubtedly lead to many more discoveries about the nature of the cosmos and our place within it. As Three-Eye Atlas continues its trajectory beyond the reach of the solar system, the full extent of its scientific impact becomes more evident. The object's brief stay in our solar neighborhood has provided us with a wealth of data, but it has also served to raise even more questions, opening new lines of inquiry in astronomy and planetary science. The discovery of 3I Atlas has reshaped our understanding of interstellar objects, their origins, and their potential effects on star systems. As scientists continue to study the data collected from 3I Atlas's passage through the solar system, they will be refining their models of how objects from other star systems interact with our own. The unprecedented nature of 3I Atlas's discovery will likely lead to new methods for detecting and tracking interstellar objects, advancing our ability to monitor these transient visitors from distant star systems. This has broader implications for future missions that might be designed to explore interstellar space, potentially involving spacecraft designed to study these objects up close. Just as 3I Atlas served as a proof of concept for the detection of interstellar objects, future research will push the boundaries of what we can observe and understand about the forces at work on such objects as they traverse space. It is highly likely that more interstellar objects will be discovered in the coming years, further fueling the expansion of knowledge in this area. The continued observation of 3I Atlas and other interstellar objects will also enhance our understanding of how these objects interact with the interstellar medium. Interstellar space is not a perfect vacuum. It is filled with sparse gas, dust, and radiation that can have subtle yet significant effects on objects passing through it. The way that 3I Atlas has maintained its integrity during its journey through the interstellar medium provides valuable information about the durability of such objects. How long can they survive in the harsh environment of interstellar space? What factors contribute to their preservation over long distances? These questions are central to understanding the life cycle of interstellar objects, and 3I Atlas serves as an important case study. Another area of interest is the potential impact that interstellar objects like 3I Atlas could have on planetary systems. While the odds of a direct collision with Earth or any other planet are low, the possibility that objects from outside the solar system could perturb the orbits of smaller bodies, such as asteroids or comets, remains an important consideration. The gravitational influence of 3I Atlas, although small, may have had an effect on objects within the solar system, potentially altering the paths of nearby asteroids or influencing the dynamics of the Kuiper Belt or the Oort cloud. Such interactions, while unlikely to cause major disruptions, still offer valuable insights into the interconnectedness of objects within the galaxy. The passage of interstellar objects like 3I Atlas underscores the fact that our solar system is not an isolated entity, but part of a much larger cosmic framework. The study of 3I Atlas has also sparked discussions about the broader potential for interstellar travel and exploration. As the possibility of human missions to other stars becomes more plausible, studying the paths and behaviors of interstellar objects could provide useful lessons. The movement of these objects traveling vast distances across space offers insight into how we might one day navigate such distances. Just as 3I Atlas moved through the solar system, future spacecraft might one day venture beyond the solar system, and the lessons learned from studying interstellar objects could inform the design of those missions. Understanding the dynamics of objects like 3I Atlas could help develop spacecraft that are capable of navigating through similar environments, The concept of panspermia, the idea that life could be transported between stars by interstellar objects, has also gained renewed interest as a result of 3I Atlas's passage. While there is currently no evidence linking 3I Atlas to life or organic material, the idea that interstellar objects could potentially carry the building blocks of life across the galaxy has profound implications for the search for extraterrestrial life. If objects like 3I Atlas can survive long journeys through interstellar space and retain their composition, they could serve as carriers of life's ingredients. This could lead to new ways of thinking about how life may spread through the galaxy and how life on Earth could have originated. While this hypothesis remains speculative, the study of interstellar objects is helping to develop new models for how life might be more common in the universe than we once believed. Even if 3I Atlas itself does not provide any direct evidence of extraterrestrial life, its passage serves as a reminder of the vastness of the universe and the possibilities for life beyond our planet. If interstellar objects can carry organic molecules or other life-related substances, the potential for life to exist elsewhere in the galaxy becomes far more plausible. The discovery of 3I Atlas has expanded the possibilities for where and how life might exist in the universe, and future discoveries of other interstellar objects could bring us closer to understanding the conditions under which life can emerge and thrive. 3I Atlas also highlights the need for continued investment in space exploration and astronomical research. The object's unexpected arrival in the solar system underscores the importance of maintaining and expanding our observational capabilities. Interstellar objects are rare, and the window of opportunity for studying them is often brief, but they offer invaluable insights into the universe. The discovery of 3I Atlas, made possible by the Atlas Survey and other observational efforts, serves as a reminder of the potential rewards of investing in space research and technology. As astronomers continue to monitor the path of 3I Atlas and refine their understanding of its behavior, they are laying the groundwork for future discoveries that could fundamentally alter our understanding of the cosmos. As we move forward in our exploration of space, the legacy of 3I Atlas will continue to shape the way we approach the study of interstellar objects. The data collected from its passage through the solar system will serve as a baseline for future research, and it will help guide the development of new technologies for detecting and studying other objects from outside our star system. Whether or not 3I Atlas is the first of many interstellar visitors or a rare anomaly, its discovery represents a significant milestone in our journey to understand the universe. The journey of 3I Atlas, although fleeting, has sparked a revolution in our understanding of the universe. It has opened a new chapter in the study of space, revealing the interconnectedness of star systems and the dynamic nature of the cosmos. As the object continues to move through space, the lessons learned from its passage will inspire future generations of scientists, explorers, and dreamers driving the quest to explore the farthest reaches of the galaxy and to unravel the mysteries of the universe.